problems with logs. Business students, don't trust Donald. Don't trust Donald. I got Donald a chocolate slice, and I got one for me. And I said, here you go, I got us two. I left the office, I came back 5 minutes later, and he said, oh Stephen, I'm very sorry, I accidentally ate both. That's a true story. Accidentally ate both.
Who's that?
You don't trust him. Okay, so if you can open up now the next lesson, which is the practical problems on exponential and log. Sean?
Yeah.
You have it open?
Yes.
Not yet, come on. Can I borrow the book, please? Thank you. Okay. Page 54. Yeah. English. Thank you. So what we're going to look at in this class is how to use exponential and log for practical word-based problems. So just like the last lesson with the AP and GP, I'm not going to do all of these, but I'll do a couple of them to give you the idea, and I'll do the important ones that I think you should all see me do. So I'll do definitely number one, and yeah, maybe we'll do a business one and an engineering one as well. But we'll all start with number one here. So if we look at these as examples. So for this lesson, what's wrong? For this lesson, there isn't any formulas because we'll just be using the formulas we had from the previous lesson. So I can just go straight in with some examples here. So the first one is the temperature, that should be in Celsius, of a cup of coffee is given by this equation. 27 plus K E minus 0.2 T. But we don't know the K here. So this one's not too bad actually. And here I ask you to find the K, and I give you some information. I tell you at the beginning the coffee is 65 Celsius. So you know that at the beginning we have a 65 as the answer. And you also know at the beginning the time is 0. So this is enough to give you the K. The K is 65 minus 27. What's that, 38 or something? 38, yeah. 38. So you have temperature equals 27 plus 38 E minus 0.2 T. That's the first part done. So this... Yeah, what the heck is that? That's a 38, believe it or not. Yep, here. Yep. Oh, yeah, it needs to be put a bit to the left actually. KJ? Yeah, actually, yeah. Andrew, go ahead.
Oh.
Now hang on, be careful. Don't mess up your hair. Okay. Good. And fix the hair. Okay, so that's the first part there. The second part now is, oh, but and I didn't say this, not that it was important just yet, but the time is in minutes. So now the second part is, to the nearest minute, how long until the temperature is 35? So I want to know when, so that means find T, will the temperature equal 35? Okay, let's see what we get here. So I want to know when will it be 35. So 35 equals 27 plus 38, E minus 0.2 T. Okay. Taking the 27 to the left, what's that, an 8 is it? 8 equals 38 E minus 0.2 T. Dividing by 38, I get this.
The power.
Oh, sorry. What happened there? Thank you. 0.2. A little part here. Okay, next we'll have to put a log on both sides to cancel the E. So I'll put a log here and I'll put a log here, and that cancels that. So can someone hit in please log 8 over 38, ln 8 over 38? What do we get? And make sure you use ln. Yeah, equals minus 0.2 t. So t is 1.56 over 0.2. That's about 8 minutes or something. So to the nearest minute, is it about 8? Yeah. 8 minutes is the answer. Yep. While I zoom out. Okay, are you writing that down? Yeah? Do we have it? So, do we have that? Yeah. So I know that this type of lesson you find difficult because the last lesson on APGP was a little bit difficult. So I think what I'd like to do is to take turns doing some of these questions together. So I've just done number 1 as an example. Number 2, I'll let you try it for 2 or 3 minutes before I do it. So try number 2 here with the bank account. And I'll open it up here so I don't have to borrow.
How many days?
Decimal? Is it, what's your asking?
How many days?
365. 365. Okay, while you're doing that, let me just check the attendance here. Alvin?
Yeah.
Amelia? Tony?
Yeah.
Clement?
Yeah.
Jonathan? There you are. Dana?
Yeah.
Yeah. Dylan? Drew? Hanukkah? Alright. Yash? Eric? Andy? Dennis? You're back. Sarah
Yeah.
and Fahad.
Yeah.
Okay. So all the business students are here, okay. Andrew?
Yeah.
Bruce?
Nope.
No, great. Good, that suits me fine. Monica?
Yeah.
Yeah. Chrissy? Yeah. Jerry?
No. Go away.
Go away.
Be nice, Bruce. KJ? Yeah. Chu? Lee?
No.
Victoria?
Yeah.
Sean?
Yeah.
And Sammy?
She went for GNIB.
NIB, isn't it? Okay. Right, let's have it. Are we still working on question 2?
Almost done.
Almost, okay. Okay, should be nearly finished number 2 now. Can I do number 2?
Yeah.
Okay. Finished. Sean? Finished?
No.
Can you do number 2?
No.
Okay, no, all right. One more minute, and then I'm doing it. Who got it? You got it? I heard a yes somewhere. Did you get it?
I think it's me.
Oh, that was you? Okay. A bank account grows over the course of a year. The growth model is B equals A E K T, where T is the time in days. At the start of the year, the bank balance is £100. At the end of the year, the bank balance is £103. So this is when the time is 0, and this is when the time is 365. Using the formula here, work out the A and the K. Alright, well this here is useful because if I put that in, I get 100 equals AE0. So A equals 100. Yeah?
Easily one, because day one.
At the end of the first day, it'd be 1.
Yeah.
But at the beginning, when you first put it in, at the moment you put it in, it's 0. Because no time has passed. When we say t is the time, we mean the time that has passed. So 0 days have passed on the first day. Yeah?
Yeah.
Next. Using this. 103 equals 100 EK 365. So I get 1.03 equals E 365K. Putting a log on both sides, they cancel, and dividing by 365. K equals 0. 8, 10 to the power -5. So 0, 1, 2, 3, 4, 5, 8, 1. One more place? Or that's it? Okay, 8, 1 then. Fine. So, yeah. Now we have the bank balance is 100 E 0.000081 T. And finally, that was part A. Part B is what is the bank balance after half a year. So that would be B equals 100 E 0.000081. Then an extra half a year would be 1.5 multiply 365, whatever that is roughly. So yeah.
Doesn't it say further one second, like 1.5 years? Or
after a further half year. Correct. Half a year further from when you very first began is 1.5 years from the beginning. Yeah. So that is, let me scroll up. Did you get about £104? 53? Roughly. Okay. Let's look at 3 together again. So when you're ready, give 3 a try. And I should point out, let's see, about half of these questions I've seen, like I've taken them off of exam style questions. So question 1, 2 and 3 so far are like exam questions. In fact, number 3 was an exam question, I think maybe in 2013. That's why I used 2013 in the question. Yeah. So these are exam questions. This is what it's like in the exam. Number 3 was a section B question. So try number 3 now, and then I'll do it in a moment. It has 3 parts. Number 3 now. Can I scroll up, or you're writing this down? No. Does anyone need a little bit of help to get started? So just to give you a bit of a hint in case you're stuck, in part A, what I mean is you can say that the energy used by the town is exponential. That means you can write it in this form, AEKT. And I tell you at the beginning of the year, it's using 12 megawatts per day. But the unit's not important. It's just 12 units of energy consumed a day. And then at the end, 365 days later, at the end of the year, the energy consumption is 13. So this is a lot like the previous question. So you should be able to do this. Give it a try. And then in part B, if you're stuck, what I mean is make it a linear formula. So the energy equals MT plus C. That's what I mean for part B. Yes.
How can we get that E for AEKT formula?
From the question, when I say that the energy is exponential, do you see that word? Are you asking me how do I know this? Yeah. If you look in the question, do you see 3A? Model the energy consumption of a town to be exponential. That word exponential means that formula. No? You don't like that?
Yeah, I do.
Okay.
Is that only one sentence we can know this?
No, it's worse. In only the one word we can know this. The word exponential tells me this.
Does that memory this?
It's just English. You need to know that the word exponential means this. Just like the word linear means this, and the word quadratic means this. You know, it's just vocabulary.
Okay.
Yeah, maths vocabulary. Okay, let's have a look at this. So for the first part, I hope you all got the value of A. It's 12. Now, let's get the K. So we have 13 equals 12E 365 by using this K. Right, so what should I do next? Should divide by 12, and next log, we'll cancel that, and next, yeah, divided by 365, and after those three steps, what I'm left with here, that's the K. So what did you get for K? 0.00022193. So you have the energy in the town is 12E 0.00022193 T. Yeah? Do you all get that? Yeah, roughly that. Now, part B is you say that it's linear. Guys, please. Okay? Part B, you say that it's linear. So the energy is equal to MT plus C. Again, you know at the beginning, the energy is 12. And at the end, when the time is 365, the energy is 13. Isn't that it? Yeah. Okay, so let's put this in. 12 equals 0 plus C, so C equals 12. So now you have energy equals MT plus 12. And let's put this in. 13 equals M times 365 plus 12. So then that means M is 1 over 365. So now you have this formula. We had this one earlier. And now we have, if I can squish this up a bit more. Can you still see that? Yeah. And you also now have energy equals 1 over 365 T plus 12. These are two different formulas for energy. Will they give the same answer? Well, it depends when I'm asking about it. So, in the first graph, here is time and here is energy, and the shape will look like this. In the second graph, here is time and here is energy, and the shape will look like this. Both here and here, here and here, the answers will be the same at the 1 year mark. And of course, they're both 12 at the beginning. You can see here, it's 12 at the beginning, and here is 12 at the beginning. But will they stay the same? No, because what will happen to this graph? It will grow faster than this graph. So in part C, I want to know how different are they after another year. So let's compare the two. In the exponential case, we're looking at the difference between 12e 0.0002193. 2 years is 780 days, is it? Is that 2 years of days? 730. Oh yeah, 730.
Yeah.
And then for the other one, it would be 730 over 365 plus 12, which is obviously 14. So this is 14. What is this one? It's going to be a little bit more than 14, isn't it? It's going to be 14 point something. Zero eight. So the difference between the two models is 0.08 megawatts per day. Although the unit's not important here. In real life, which model do you think is more accurate? The exponential model or the linear model? Why? No. Good try. That's nearly the same thing as more decimal. It doesn't make it better.
The linear one is like estimate the middle of that and when you went through the line.
No. Good try though.
Okay, I tried to.
Yeah, so give someone else a chance now. Anyone? Why you're all right. The exponential is better, but why? No.
Oh, because.
Yes. You're going for 4 goals. Go for it.
Because in practical,
Yeah?
the energy doesn't move in linear.
You're getting closer, but not quite 100%, but you're getting closer.
Now I got that.
In real life, when you look at town sizes, the growth of the population of the town is exponential in real life. So towns don't grow in a linear way. For example, if a town has a population of 1,000 and next year it's 1,100, next year is not 1,200. Town sizes don't grow like this. You know, it'd be more like 1,000, 1,100, and then maybe 1,250. You know, it's not linear growth for towns. It's usually an exponential growth, although maybe a slow one. This means that the power the town uses increases exponentially, because roughly more people mean more power. Now, it's not perfect, because in real life yes, the town will increase exponentially, but then it might level off. Yes? Or in some cases, the town might increase only to decrease again. It's not accurate, but roughly speaking, exponential will be a good estimate for what's happening here. Will this estimate be good forever? No, definitely not, because we know that it won't increase like this forever. So at some point it will become a bad estimate. But for small time it will be a good estimate. Yeah. In the exam they ask the students between the two models which is better. Or they might say for the exponential model, why will it not be accurate forever? You know, they might ask you something like that for 1 mark. So as long as your answer is reasonable, you should get the 1 mark. Reasonable. It doesn't have to be perfect, but it has to be reasonable. So if you said, it doesn't have to be right. If you said, exponential is not good because it increases forever, which is not like real life. Yeah, something like that would be fine. Yeah. Okay. Let's continue now. So we did 1, 2, 3. So number 4 is back to a money question. Number 4, please.
I'm sorry, we haven't.
You need to write it down? Yeah. How far back now? Just here?
Yeah.
Okay.
Thank you.
That's okay, yeah. You can try now. Try number 4.
Huh? I have no idea what it is.
She puts money, basically the question is, you put money into a savings account, and each month you get 1% growth.
Okay.
How long? Until your money has doubled. It is GP. It is GP. You don't have to. There's no need to use the GP formulas, but you're thinking: are you multiplying by a number each time?
Yeah.
Yeah, it is geometric like this. Yeah. Okay, this one isn't as long, so just 1 more minute here. Got it? No. Got close? Not even. Good use of English, by the way. Your answer is 7, and the real answer is 70. Decimal point? gold star for you. Okay, guys, let's have a look at this now. Some of you got it and now are eating sweets in celebration. So, let's have a look here. You put some money into the bank. It's not important how much, because the question is, how long does it take to double? If you wanted to, you could pick a number. So you could imagine that you put in 100 and you want to know how long until it becomes 200. You don't have to use a number. You can just, you could say something like x to 2x. That's fine. But let's just use 100 as an example. So after 1 month, it's become 101 because it increases by 1%. And after another month, it becomes 102.1, is it? What exactly is it? It's not exactly 102 because it's 1% of 101. 0.01 and so on. So each time we're multiplying by 1.01. So as you were saying, it is a bit like a GP where you have your bank balance will equal A or n minus 1. Like this. Where n, we'll say, is the day number. So for example, if n equals 1, that's at the end of the first day. Yeah? Now we want to know how long until we get 200. Well, we divide by 100. And what happens next? We put log on both sides. So we get log 2 equals log 1.01. N minus 1 comes down. So we'll get n minus 1 equals log 2 over, I scroll up, log 2 over log 1.01. That's 360, no, that's 69 about, isn't it? 69.6 for this. So that, about 6. N is roughly 70.6. It's about 71. That is not like it's on the 71st day, which is about 70 days.
How come you get the formula?
How come I get the formula?
E equals to 100, 1.01.
Dude, it was your idea. Yeah, it was your idea. Where did I get it from? Why is it 70 days and not 71? Because, for example, when n equals 1, that's the first day, which means that's after 0 days have passed. You know, if it's the first day, no time has passed. It's the first day, you're at the beginning, no days have passed. Oh, sorry, these are months. Yeah, thank you. Sorry, these are months. So after 70 months pass. Yeah. And that's fine. It will give you the same answer, yeah. Because last time we learned that this can be written in this form. Remember when we did the equivalent identities? Yeah. And I'm glad you did it that way, so you've seen it both ways now. Which is good,
Can you do the explanation?
Oh, fine. I will now in one moment, once people write this down, yeah?
Do you have to use Fn? Because this is like ARN.
No, because what you would be doing there is adding the bank balance each day. And that's not how money works. So if you had 100 euros in the bank yesterday, and you have 90 euros in the bank today, you do not have 190 euros. You have 90 euros.
What?
Think about it. If in the bank you had yesterday, your balance is 100, and you spent €10 and your balance is now,
90.
do you have 90 or do you have 190?
But this is not.
No, just answer that. Do you have 90 or 190?
90.
Yeah, so it's not S. You're not adding the daily balances. Are you sure? You don't sound convinced.
It's like an answer.
Okay. I'm going to do this again using the exponential approach. Can I scroll down now? Yep. Okay, so you also know that the bank balance will grow exponentially. So you can say that the balance equals AEKT. At the beginning, it doesn't matter. A can be €100, €1,000, or €1. It doesn't matter. Let's keep it the same and imagine we use €100. So the bank balance would be 100 EKT because you want the balance to be 100 at the beginning. After 1 month, what's the balance? After 1 month, what's your bank balance? 101. Why? Because the 1%. Yeah? So after 1 month it should be 101. So you have 101 equals 100 EK1. 1.01 equals EK. What's next? Log. Okay, so what's K here? It's log 1.01. What's that, please? That would be 0. Okay, so the bank balance is 100 E 0.00995T. I want to know when will the balance be 200. So now I have 200 equals 100 E 0.00995T. I get 2 equals E 0.00995T. Log, cancel, divide. So I get T equals 70. Yeah.
I use the F1% of my kids.
You put in K as 0.01. I don't know if that's a bit of a coincidence that it worked. Because it is close to 0.00995. But not close enough for me. I think the reason it worked was by accident. The K is not necessarily 0. Yeah, it was an Andrew incident. Yeah, I think this is just by accident, I'm afraid to tell you. Yeah.
Accident fine.
Yeah. Okay, so now at this point, we've gone through 4 examples together, so I think you're starting to get the idea. It is hard, but this is what you have in the final exam, so you need to practice. So I want you to work on these for a few minutes, okay? The homework, I need you to go to at least 7. So I want you to work on these for a few minutes. If you can get up to 7, that would be great for homework. We've already done 1 to 4, so try and do 5, 6, 7 now. Okay? And we can do them in the tutorial if you get stuck. So now, try 5, 6, 7. Maybe. Maybe not. I think it is part of the exam, because I remember writing a question that requires the use of e's and logs, a word-based practical problem. Hey! Working, please. Put the light on. Put the light on. No, no, no. He's going to put the light on for me. Light. Thank you.
Really the laptop?
In a few minutes, after we do this for a little bit. Not right this second, but you will need it. Why?
Can I go to my room?
You don't have to have it. It's useful to have it.
I want to get water. That's
Be quick. Don't come back with a frappuccino. You're only getting water, okay?
Chemical water.
Sorry. Iced coffee.
Okay.
Because I'm picturing her coming back saying, it's not a frappuccino, it's a nice coffee. It's mostly water.